Hello friends, welcome to the class of quality assurance. And this quality assurance is one of the subject that is in B Pharm course in the 6th semester, and the code of this subject is BP 606T. And today I am going to cover another very important topic of the unit 5 of quality assurance syllabus, and the topic is the calibration of pH meter. This is another very important topic related to the whatever the things that are happening in the pharmaceutical industry, and this is one of the pH meter is one of the very important and basic equipments that is used to measure the pH, and that is why this is another this is the part which is actually included in the quality assurance syllabus. So, let us start without wasting our time. I am Dr. Alankar Srivastav, Associate Professor from KITE Group of Institution. So, let us start of the topic, that is calibration of pH meter. So, first of all, what is pH meter? So, pH meter is an electronic electronic pH meter. It is used to obtain more accurate pH measurements. A pH meter is an instrument used to measure hydrogen ion activity in solutions, or in other words, this instrument measures the acidity or alkalinity of a solution. So, now you can easily understand what is pH. pH is actually measurement of the hydrogen activity of any solution. So, in order to measure the hydrogen activity, or in other words the acidity or alkalinity of any solution, we are using the pH meter. The degree of hydrogen ion activity is ultimately expressed as pH level, which generally ranges from 1 to 14. Now, you can easily understand that if the solution of any if the pH of any solution is 7, that means it is neutral, and if the pH of any solution is below 7, that means it is acidic in nature, and if the pH of any solution is above 7, that means it is alkaline in nature. So, for measuring the hydrogen ion activity, we are actually using the pH meter. That these things that we have already discussed. In the case of a neutral solution, pH is equals to the 7, and that simply means the overall hydrogen ion as well as hydroxyl ion activities are similar, and that is why the pH is 7. And in the case of acidic solution, the pH will be less than 7, that means there is more hydrogen ion activity, or there is a more concentration of proton ion is there. And if the pH of any solution is above 7, that means there is a less hydrogen ion activity and more hydroxyl ion activity, and that is why its pH is above 7, or in simple words, the solution is alkaline in nature. Or in the case of acidic, the solution or acidic solution, the hydrogen ion activity is more as compared to the hydroxyl ions. So, before proceeding to the main part, that is calibration of pH meter, the first thing that you need to understand the how the pH meter actually works. So, in the pH meter, basically there are different electrodes, and these the combination of these electrodes are made in such a way that it measures a minute potential which arises because of the change of ions. So, basically as you can see in this figure, there are basically two electrodes in the center part of the pH meter that you can see here. The center part of the pH meter is a silver electrode, and basically this is a silver electrode or silver wire which is coated with silver chloride. And there is another electrode which is actually represented here by a green color. This electrode is a reference electrode. This electrode is a reference. This electrode is a reference electrode. This electrode is also made up of silver, and which is again it is coated with silver wire, coated with silver chloride. But here you can see there are actually two different solutions. The first electrode or the reference electrode is actually dipped in the reference solution, and which is actually saturated KCl solution. Whereas, these electrodes which is actually represented here in the blue color, this electrode is actually dipped with filling solution which is actually pH 7 buffer. And the lower portion of this electrode or the this pH meter is dipped into the solution for which the pH is determined. In this figure, you can also see the another electrode kind of a thing that is represented here in the yellow line as in yellow line. This is actually temperature probe, and this temperature probe is to correct the temperature variation. You can easily understand there is a change in the potential because of the change in the temperature. So, this provision is made to control the performance of the pH meter in the case if there is a change in the temperature. Now, here is the glass electrode. This is the glass electrode, and this is a proton ion sensitive electrode. This is a sensitive glass membrane. This bulb is actually made up of a sensitive glass membrane, and through this actually we are measuring the acidity or alkalinity of any solution. So, when we dip this pH meter in any solution, what is happening here? There is a change in the overall accumulation of the ions near to the boundary of this electrode, and because of this there is a change in the potential, and this change in the potential is actually measured by the electrode configuration which is given in the pH meter, and through this the results are displayed in the monitor. So, what are the different steps are involved in using this pH meter? Suppose in the case if the solution is acidic, that means there is a more H plus ions are outside. If the solution in which we have dipped the pH meter is more acidic, that simply means the more protons are there outside, and these proton ions migrate outside to inside the glass membrane, and in this case the outer glass membrane becomes positive and the inner solution becomes negative. So, the potential difference arises, there will be a certain rise in the potential, and this potential difference, because of this potential difference current start to flow, and this potential change is actually sensed or measured by the reference electrode, and after that there is a pH calculation by Nernst equation by the pH meter, and after this calculation the value is actually displayed in the monitor. So, these all are the simple steps through which you can easily understand how this pH meter works. So, now how we can measure the pH of any solution? By using pH meter. The first thing we have to ensure that the meter is set to the pH mode and adjust the temperature to 25 degree Celsius. This is a important thing, because the potential or the current flow may change with the change in temperature, and that is why it is always better to use the pH meter when the solution as well as the temperature of the pH meter is close to 25 degree Celsius or room temperature. Second thing, place the electrode in the sample to be tested. So, we have to place the electrode that we have just seen in the previous two slides, in the last two slides, that is actually dipped into the sample of the solution. Third thing, the pH of the solution appears in the display. So, directly after some time, the pH meter displays the pH of the solution. But before that, before taking the reading, you should allow the display to stabilize before taking your readings. Then in the fourth step, rinse the pH electrode and place it back in the storage solution. Actually, we are keeping the electrode in a storage solution, and this storage to keep the pH meter moist or the electrode in the moist condition, and if it becomes dry, that means it will not function properly. So, the pH electrode after the usage, it should be placed back into the storage solution. Next thing is the applications. There are many applications of the pH meter. It is actually used in the performance of analysis in the case of pharmaceuticals, in the preparation of mobile faces for the chromatography techniques, in the preparations of various different types of pharmaceuticals, in the synthesis or various types of processes just to measure the pH of the solution. For the preparation of mobile faces in HPLC, we have to first measure the pH of the solution, and then only we can inject into the HPLC system. So, in those cases pH meters are utilized. It is also used for the food and beverage industry, because there are many food substances also in which the pH is very important. For example, the soft drinks etc., these solutions should have certain pH value, and if the pH value is not there, if the fixed pH value is not there, that means there is some problem in the solution. So, these are actually various different industries in which these pH meters are used. The food and beverage industries, the pharmaceutical industries, the oil and gas industries, agriculture industries, and the water treatment plant, in which it is used for the measurement of pH during performing various processes. It is also used for the measurement of pH during synthesis of any product, because there are some products which are manufactured at particular pH. So, if we want to know the pH of the solution, again we have to use the pH meters. So, there are a lot of different types of usages in the pH meter in the pharmaceutical industry. This is one of the very important and basic equipment that you all might have seen in your colleges as well as in the in all kind of analytical laboratories. So, now next thing is what is calibration? How we can calibrate the pH meter? The pH meter calibration is a necessary step of using a pH meter because the electrode changes over time. So, this is very obvious that there may be some change in the overall performance of the pH meter after some time. So, the calibration of the pH meter is very important. A pH calibration is a process of adjusting your pH meter by measuring solution of a known pH value. So, we have to calibrate the pH meter according to the known pH value, so that it will function or it will display the accurate result or the actual result or the actual pH of the solution for which we are measuring pH. Now, this is because the characteristic of your electrode will change over time and this needs to be compensated for. And now, you can easily understand the pH meter is one of the sensitive equipment. So, there may be after a very long time usage, there may be some kind of change is there in the performance of electrode, and this performance should be compensated, and that is why the calibration of the pH meter is required. A calibration does this by matching your pH meter to the current characteristic of your pH sensor. So, what we are doing here in the calibration process? We are actually matching the overall readings of the pH meter with the already known solutions pH, and by doing so we are actually compensating the overall performance which are actually deviated because of the long uses of the electrode. So, by regularly calibrating the pH meter will adjust the electrode based off any changes that may have occurred and ensures that your readings are accurate and repeatable. These both things or the both characteristics are very essential in the case of pH meter. The first thing, the pH meter should give the accurate result. That means, whatever be the readings that we are gaining, we are obtaining by pH meter are close to the true values of the pH of the solutions. And another thing, that it should perform in the same way, or it should give the same results when we are measuring the pH of the solution repeatedly many times. So, these both things are very essential, and through proper calibration actually we are ensuring the accuracy as well as repeatability of the performance of the or the readings that it is giving in its monitor. Now, the next thing is the types of calibration. Now, because pH cells are not ideal, they must be calibrated before use. All pH meters, these are not actually ideal equipment that one time calibration can ensure their results are repeatable as well as accurate. So, these pH cells are not ideal, it requires regular monitoring as well as calibration. These pH cells are basically calibrated with the solutions having exactly known pH, and the solutions that are having exactly of a known fixed pH are known as buffer solutions. So, these buffer solutions are actually used for calibration of pH meters. And the calibration of pH meters can be a single point or the 2-point and multi-point calibration. So, basically single point, 2-point as well as multi-point calibration represents how many points a calibration is performed at. This is actually this shows if we are actually calibrating at single point, that is actually single point calibration, and if we are calibrating at 2 points, that means that is 2-point calibration, and if there is a multi-point calibration, that means we are calibrating in a multiple points. So, what is single point calibration? Basically, this approach is used when we have to measure every time a single pH value with little variation. So, suppose if we are manufacturing any product which is having a pH of 7, that we need to calibrate the pH at the 7 only, because we are not working in any other different pH. So, in this case basically we have to use a single buffer as a reference for calibration, and usually in a single point calibration pH 4.01 is recommended. And the next type of calibration is the 2-point calibration, which is actually most commonly used for the calibration purpose, and it is best suited when if the aim is to measure a range of pH sample. So, if we have to measure a acidic value as well as alkaline value, or if you have to measure the acidic or neutral or alkaline value, this kind of calibration can be performed. So, there is a more accurate, it is actually a more accurate calibration technique than the 1-point calibration. The 2-point calibration adjusts the meter at 2 different pH values, and thus the meter has been adjusted so that its response is accurate at more than 1 point along the linear equation. The second calibration point is selected on the basis on the types of solution, that is acidic or basic, to be measured, so that the linear response can be established. And for performing 2-point validation, usually pH 7 buffer as well as pH 4.01 pH buffer solution are required. Now, the third type of calibration is multiple point calibration. Now, in the event that both alkaline as well as acidic solutions are measured using a single pH sensor, a multiple point calibration is done using 3 buffer solutions. As in the 2-point buffer solution, the first buffer solution has pH 7 and second buffer is usually pH 4.01. But in the third buffer which is included in multiple point calibration is as close as possible to the suspected pH of the solution that we are going to measure in a routine way. Now, we have already discussed that 2-point calibration is one of the common method. So, here is the procedure to perform the 2-point calibration. The first thing that we have to do that place the enough of the pH 7 buffer solutions into a small beaker, so that it can accommodate a small magnetic stirrer bar, electrodes and temperature probe. If pH meter is without temperature probe, temperature has to be measured manually using thermometer. Then remove the protective caps from the electrode and rinse the electrodes and temperature probe if fitted with distilled water using a squeeze bottle. Dry the lower portion of the bulb of glass electrode using tissue paper. Place electrode and temperature probe into the selected pH solution, pH 7 buffer. Adjust the pH showing in a display after stabilization of readings. Rinse again the electrodes and temperature probes if fitted with distilled water using a squeeze bottle. Dry the lower portion of the bulb of glass electrode using tissue paper and repeat the procedure using buffer pH 4.01. Now, there are few precautions, very important precaution. First, do not wipe the glass bulb. It may produce the interference static charge or may permanently scratch the glass bulb, affecting the electrode's response. Another thing, alkaline buffers are less stable. So, if the alkaline buffers are used, it should be freshly prepared because it readily absorbs carbon dioxide and the pH value changes if left open. So, in the that is why the pH 4.01 buffer is more suitable in the 2-point calibration. And lastly, before starting calibration, be sure the electrode and buffer are at same temperature. That we have already discussed. The temperature may change the potential of the electrode. So, this is all with the topic. Hope you all liked this video. So, thank you friends. Jai Hind, Jai Bharat.